work for what is the slope or what is the rate of change, it is a ratio. So a ratio can always be written as a fraction, and I had someone say, well, when I look at like a question like number 35. Now 35, if we are writing 35 out, and you had that on your paper, and I said you did not have to graph these because of the fractional ones, but if you were looking at 35, and we were going to graph that one, it does say to take slope is equal to the change in y divided by our change in x. So if we are starting that one, who will want to volunteer and tell me what I'm going to use for my first y point? Kylie, what do you have?
35.
35.
Our first y point, we want y sub 2.
Okay, so I'm going to have y sub 2 minus y sub 1, right?
Over x sub 2 minus x sub 1.
Okay, and what did you use for your y sub 2?
Y sub 2, I use 4 sevenths.
4 sevenths minus?
4 sevenths.
4 sevenths minus 4 sevenths. So when I look at that, and some of you are like, oh, this is a really ugly question. 4 sevenths minus 4 sevenths. What is 4 sevenths minus 4 sevenths?
0.
It's 0. And 0 divided by, does it really matter when we find what our denominator is of those two numbers of subtracting the x points of 8? Did you go 8 minus a negative 1/2 or negative 1?
Plus.
Okay, so if you might have had, when you started that, you might have had 8 minus, and then it was a negative 0.5, and you changed it to a plus, so we get 8.5. And 0 divided by any number is always 0. So, yes, they were ugly numbers in that fraction. You have a fraction within a fraction, but they worked out to be pretty nice. So, when you were looking at that in 35. So in 37, if we are looking at 37 and we are looking at our two numbers, you're going to have those decimals. So as I looked at 37, in 37, Liz, if you were going to start me off with my y2 minus y1, what did you use?
3 minus 5.2.
Okay. So in the numerator, you started with the 3 minus 5.2. Okay. What did you get when you did that subtraction? Negative 2.2. And in our denominator, Josie, what did you have in the denominator of that one? What did you have for your first x2? The 3.25?
Yeah.
Okay. Minus the negative, so it was minus, and then a negative 42.25, which becomes a plus, right? And so this one, as you're looking at it, it does come out to be just a little uglier. And when you look at that answer, did you guys check the answer in the back then?
No.
And so when we looked at that answer, we're adding 42.25 plus 3.25, it should give us 45.5. You are dividing negative 2.2 divided by negative 45.5 on your calculator. Because we're kind of thinking per 1 is usually when we think about our unit rate. So you should have looked at that one, done that division. I believe that one comes out as a decimal as you're looking at it. 49, I want to look at 49. They give us this arithmetic sequence of 10, 15, and the first question says, what's the common difference? The common difference was?
Adding 5.
Adding 5, right? It says x is the number of term, y is the corresponding term in the sequence. Graph the ordered pairs x, y. That means my first ordered pair that I'm looking at is 1, 10. Right? So the first one, the first term, and the first term was 10. The next one is 2, 15. Second term, second number. The third one would be 3, 20. 4, 25. Right? And it says to list those first 8 terms. So we keep going with 5 would be at what? 30. 6 would be at 35, right? 7 would be at 40. And 8 would be at 45. And actually that sequence keeps going, thus the dots behind it. And it says, we'll now draw a line. And if you look at the line, how is part B? which we are looking at, and this one says draw a line through the points, and we are looking at that common difference. How is the slope of the line from part B related to the common difference? So what is our slope? Each time as our x increases by 1, our y is increasing by how much? By 5. So our slope is actually 5, as was our common difference, right? So the slope and the common difference are the same thing. At the end of this unit, we do a lot of work with arithmetic sequences, okay? And we have a different type of notation. So this one might have been a little difficult for you of knowing to set this part up, but you should have been okay. All right, we're going to go on to your notes. Yep.
Why is y over x? It's usually x over y.
No, it's not. The slope is not the change in x over y. It's always the change in y over x. It's always the vertical change. It's always horizontal. So make sure you take a look at that. And I mean, if you want to look back, there's many ways that they explain why that changed, but it is the vertical change going up and down always to the horizontal change. It's not an ordered pair, it's a ratio. Slope is simply a ratio. So we're getting into this next part in our notes, and this is going to be a little different than maybe what you looked at before. So writing equations. So I can write a linear equation. If we look at our I can statements, I can write a linear equation using the point on the line and the slope, and I can graph this. Now, we are starting this a little differently than when you did last year with slope-intercept. So it says when you know the slope of a line at least one point that it goes through, you can easily write an equation. The equation is given by filling it in the blanks below, where you are going to simply put your slope right out here. Then you're going to put the x-coordinate, and you're going to put the y-coordinate. Now, the reason that we are using it this way, and it says sometimes the formula might be written this way. Y equals m times x minus h plus k. It might be written this way, and it means the same thing, right? We said m is slope. This is our x-coordinate and our y-coordinate. Since this form has several names, sometimes it looks different in some math books that we are looking at. Sometimes it's called the linear vertex form. Sometimes it's called point slope form. Later this year, we're going to be studying all types of functions. Our absolute value falls into the same way. Our quadratics are going to go into the same type of equation. So when you get into your Algebra 2 class, or if you know someone who's in Algebra 2, you have an older sibling, or you have a friend that's at the high school that's in Algebra 2, they are doing the same form, and if you can get it down now, it's just going to make it much easier going forward, okay? So as you are looking at these. So in this question, it says we want to write the equation for a line that passes through the point 8, negative 4, and has a slope of 2/3. So the first thing we are looking at is this is our x1, correct? And our y1, and this is what m equals, is 2/3. So we are going to start with what was the basic form of our equation? Y equals, this is going to be our slope. It's going to be x minus, this is going to be my x-coordinate, plus this is going to be my y-coordinate. So when we look at the problem, first thing is you start your homework. At the top of your homework, you want to start with this. So what is my answer going to look like? My answer would be y equals 2/3 x minus, what's my x point? 8, plus my y-coordinate, which is negative 4. Now, if you don't like putting plus a negative 4 and you prefer to just have a minus 4, you're done. That's it. That is the equation for the line through that point. That's simple. Not bad, right? So please try this next one where you have the form, right? We have the form already, so we know it has to be a y equals. Try it and check with your shoulder partner and see if you can get it. Use the form that's up above, right? Talk to your shoulder partner right now. Shh, quiet, please.
Y equals negative 5 times x minus 3 plus 6.
X plus 3.
Yeah.
Should be x plus 3 or x minus 3?
Plus.
So it's minus, and then you have that negative 3, so you got to be really careful. So that is going to be a plus, and then this is a plus. So it is always going to be, when you look at the form of the equation, It is always a subtraction here. And the main reason is when we are looking at that, it's the change. When we think of slope, slope is the change in our x's. And so when we look at the change in x, it's always a subtraction problem as we are looking at it. Okay? So it says, if we are looking at the asked to graph, okay, and you're given an equation in this form, first thing you want to identify is what is your slope. So our slope in this is 2/3. And that means we're going to rise 2, right, and run 3. And then we want to look at what's our point. So our point is, remember it's x minus our x coordinate, so it's going to be located at 2, 1. Do you agree? Okay. So what you are going to do is you're going to go to the point. This is your start point. Okay. So we go to the point right here at 2, 1, and then you rise 2 and run 3. And you're going to do that at least 3 times because I need at least 3 points on your graph to get a straight line. I know it only requires 2 points to make a straight line, so in this case, if you're going off the graph, you might go down 2 and back 3. So I want to see 3 points on your line, and then you're going to connect those points with a line, okay? It says when you graph an equation, you should draw a solid line with arrows on the ends, both ends. This is because it's continuous. Decimals and fractions are in our domain, and it also continues on in both directions. So if you don't put the arrows and you make it a segment, I'm going to mark it wrong, right? It's not the correct answer. All right, so now you're going to go down to this next one. First thing you're looking at, what point does it go through? Be really careful that that general equation, right? The general equation was y equaled, it was our m times x minus the x1 plus y1. So what is our ordered pair that we are looking at? Our x should be -6, and our y should be 4. Now notice the scale on this graph, it goes by 2, so we're going to go to -6, 4, and we're going to place our point. It says, what's your slope? Our slope is 1/2. Keeping in mind that that's my rise to run. So if I am looking at graphing this one, as I look at this graph, I am now going to go, I know my slope has to be going up. In this case, if we are looking at it, it's a -1/2. Yes. So, -1/2, not positive. So, the question came up this morning is, how do I know if I should go up or down from this point? Now, keeping in mind that our scale is different, so we're actually going down 1 unit, that's like in the middle here, right? And over 2 to here, down 1 over 2, right? Down 1 over 2, so that when we graph that, you got to be careful for the scale. Down 1 over 2 units, is that the same as just getting this point? Yes. It's a negative slope. You can remember by looking at the slope guy, negative slope has to go down. Could you have gone up 1? If you go up, then you have to go back. That's that negative to get that point. So please connect those points with a straight line. All right? And we're going to put arrows on that also. Questions? So it says, I might ask you on the quiz or on the test, give me another point on your line, right? I mean, you could give any of these points in here. All of these points are on the line, but sometimes the easiest one would be, oh, there's going to be another point at, this is located at 2, 0, right? This point is located, if we are looking at this one, at -2, 2. So if I ask you to give another point on the line as you look at that, okay? So we're looking at this next problem on the top of the next page. And the first thing it says is we need to find the slope. So, easiest way to find the slope when you're looking at a graph line is to do what? Slope is a ratio, right? Would you look at using the equation or would you look at counting? If you're looking at the graph. Counting, right? I think I count. If I'm looking at a graph, can I count how far up I had to rise? which was what?
7.
Rise of 7. Count again. And my run is 3. And if you check that, right? 4 minus a negative 3. 4 minus a negative 3, right? Those are my y coordinates here. And if I would have taken my x, which is 1 minus a negative 2, do I get the same answer? 7 over 3, yes. So it doesn't matter if you count it or if you would use the formula. It says now we're going to pick one of our points. So we're going to, on the top, do the first point, and then we're going to do the second point. So if we look at, this is our first point. When I think of this as my first point, it's the first one I see. So I'm looking at -2, -3. If I'm going to write that equation, please do that right now. Y equals our slope, 7 over 3, x minus a -2, which becomes a +2, minus 3, right? I'm going to have you do the other one also, just to practice, but usually you only have to do one of them, okay? So now if you are doing it with 1, 4, give me that answer also, okay? So this is the first answer, do that second one, please. Yes. Okay, everyone agree? Okay, now, someone said, well, how do I know if I did it right? How can I check that like these two things come out equal? We will talk about putting it in that slope-intercept form a little later, but right now we're going to keep it in this form. So I will show you how we're going to look at that. So it says look at the table for this next one for the story problem, because we're always going to try and relate it to our real-world problems. The table shows the altitude of a hot air balloon during a linear descent. So the hot air balloon is up, it's coming down, right? Write an equation that gives the balloon's altitude at any time. First thing we need to write an equation, if we're going to write an equation, you need two things. You need the slope and you need a point. Does it matter which point you pick? No. If you want to pick the first one, someone pick the second one, the third, the fourth one, it doesn't matter, okay? I'm going to pick the first one just because it's the first one I see, and usually that's what most people will go with. So that's my point. I'm going to now look for the slope. Slope is y2 minus y1 over x2 minus x1. If you were going to start me out finding the slope, which point, what do you want to use for your points? Which two? 10, 640, and 35, 90. Does it matter which ones we pick? We could pick any two on here, right? All right, so if we do that, we are going to be taking 590, right, minus 640. And if I do the 590 first, I must take 30 minus 10. So if we are looking at our slope, please change yours when you're looking at this. So we're going to get what when we subtract it? A negative how much? Negative 50 over, so a negative 2.5. Does it make sense to change it to this decimal negative 2.5 for this situation? Yes, because we're talking about what's happening in this situation. Negative 2.5 meters, right, per 1 second is our unit, right? Because these are seconds that we were looking with, right? These were our meters that we were looking at. So it makes sense to write it like this, but now we have to finish our equation. So there's many answers when we take a quiz or a test, if I give you a table like this, that would be correct, right? I'm looking for the slope, negative 2.5, times x minus, if we use this point, x minus 10, plus 640, right? So when I'm looking for the equation, anytime it asks you to write an equation, I have to have a y equals. I'm looking for in that equation a slope and a point, okay? It says, well, what does the slope mean in the context of our problem as we were looking at this? And we kind of answered that up here, and that we don't want to necessarily leave it as -5/2. Could you leave it as -5/2? Would that be incorrect? If you said -5 meters per every 2 seconds, that would be fine too, right? Because you're explaining it, or -2.5. What does that negative mean? That we're doing what?
Going down.
We're going down, right? We're descending. So, slope of -2.5 means it was descending 2.5 meters per second. Again, I would have taken descending 5 meters per second also. But usually when we get to our slope, we want it as a unit rate, so we want it over 1. Okay. Oh yeah, over 2 seconds. Good for catching. Okay. All right. So the homework tonight is the workbook towards the back. Do like 1, 2, and check or answer, right?